All right, in this problem, we have this slide going in the x direction. It is restricted to move in the x direction only if we consider this as x direction. And this is a piston on a bar that it is going in the y direction, and it is going up with a speed of 0.1 meter per second. So we want to find what is the velocity and acceleration of B and the velocity and the angular velocity and the angular acceleration of the bar AB when theta equals to 30. So the first way we do it is to use parametric method. We see that x squared plus y squared equals to L squared. So this is a good point to start because we have this geometric relation and we can do the derivative of this one. So don't forget that when we do the derivative, it is not just 2x, it is 2x x dot, because x itself is a function of time. So plus 2y y dot equals to, and because L is constant, so it is 0. Then from this, we can get that x dot equals to negative y dot divided by x. And because we know theta, so this is y is L sine theta, and x is L cosine theta, and y dot is 0.1. So this is 0.1 times tangent of theta. Now, if you want to find the acceleration, I can do the derivative of this one, or I would prefer to work with this one. And because it goes up with that velocity, which is constant. Oh, it is constant velocity. So if I do another derivative of this one, and let's cancel out 2 first. So I would have x dot square, because it would be x dot times x dot, which is x dot square, plus, let's use the other color here. So I would have x dot square plus x double dot equals to negative y dot square plus, or negative, minus, because I brought this to the other side, minus y double dot. And because we said that it is going with a constant speed, so this is 0. So I get x double dot equals to negative y dot square, and y dot is 0.1. So it is negative 0.1 square minus x is L cosine theta. Oh, oops, sorry, minus x dot square. And x dot, we already found it. It is 0.1 square tangent 30 square. This is x dot square divided by L divided by x, which is L cosine theta. And by the way, you factor out that, I would get 1 plus tangent 30 square, and 1 plus tangent 30 square is 1 over cosine square. So we can simplify that even more, but at this point, we are not doing that. We are just leaving like that, and we can plug in 30 here as well, cosine 30. So let's just do that cosine 30. All right. So now we want to find theta and theta dots. We can say one relation that we can use is we can say that tangent theta equals to y over x. Then we do the derivative and we have both y and x in our derivative. And so that is one way. What I'm saying is that I can say tangent theta equals to y over x, and then do the derivative of both sides. I would get theta dot times derivative of tangent is 1 plus tangent square, right? And then it would be derivative of numerator times denominator. You see y x dot y dot x minus blah, blah, blah over x squared. So this is one way, and I can do more and more derivatives, but I prefer to not use this one because I have to deal with two derivatives. How about if I just say y, because I know the derivative of y is a number and second derivative is is 0. So I would say y equals to L sine theta. Then if I do one-time derivative, I get y dot equals to theta dot L cosine theta. So from this, I get theta dot equals to y dot, we already have it, 0.1 divided by L cosine 30. And then we can do another derivative of this one. I will get y double dot equals to derivative of this one, theta double dot L cosine theta. And then keep this derivative of this cosine theta again. Theta is a function of time. So derivative of that is theta dot negative sine theta. So it would be negative theta dot square because I already have one theta here, theta dot here, sine theta, right? And I already have that from here, so I can find, and this is 0, right? Y double dot is 0. So I can get theta double dot L cosine theta equals to theta dot square L sine theta. Let's cancel out L. And then I have theta double dot equals to 0.1 L cosine theta 30 to the power of 2 times sine 30 divided by cosine 30. So if I plug in numbers, I get theta dot and theta double dot. Now let's solve it with the other way, dynamic way. So we know even this stuff, right? We know the problem statement, so let's erase this. All right, so for the other method, which is more formal vectorial method, and it works all the time, and I prefer this method, I would say VB equals to VA, because this is a rigid body, and I know the constraint for B, and I know the velocity of A. I can relate these two velocities through this relation for the rigid body, omega cross AB. So I would say velocity of B equals to velocity of A plus omega cross that vector, AB, all right? So velocity of B is, this is two equations. It is vectorial in 2D, so I have two components, I and J. So, and the unknowns are one for the magnitude of BB because we know the direction, and the other one is for magnitude of omega because we know again the direction. It is in the k hat. So I would write it VB I hat. So I can solve it. VA equals to 0.1 J hat plus omega K hat cross AB is L negative L cosine 30 I hat negative L sine 30 J hat. So I get two equations for I and J components. For I get VB equals to, you see, K hat cross J hat. This is cross J hat. K hat cross J hat becomes negative I hat because IJK and K cross J is negative I. And I have another negative here, so it is positive. It becomes L, it becomes omega L sine 30. So I get this equation for the J component, I get 0. On this side, I have 0J. On this side, I have 0.1. And K hat cross I hat, it becomes positive J hat. So I have negative here, negative L omega cosine 30. So from this, I get omega equals to 0.1 divided by L cosine 30. And if I plug it in back here, I get velocity of B, omega, which is 0.1 L cosine 30. So L would cancel out. I would have 0.1 tangent 30. So if we compare this to this one, we see that it is the same. And this one, for that one, we had a negative because x was decreasing. So x dot was negative because x is decreasing. So x dot should be, the slope of x should be negative. But because we are using vectorial notation here, that is I hat. It means that the velocity is in the I hat. It is positive because we said it is VB I hat, right? So I prefer this one. Even it is easier to follow. You don't have to see x is decreasing, increasing. You would see that it is in the I hat. So for the acceleration, and by the way, we would have one equation. I mean, with one set of equation, we solve both of them. For acceleration of B equals to acceleration of A, right? Which is 0 plus alpha cross AB minus omega square AB. Don't forget that this is for two-dimensional case. In fact, it was omega vector cross parentheses, omega cross AB. But for 2D problems, that omega cross AB becomes negative magnitude of omega square AB. So now this is 0 because we said that this is going with constant speed. So AB is again in I hat. So I get AB I hat equals to alpha K hat cross again AB, which is the same thing here, negative L cosine 30 I hat minus L sine 30 J hat minus omega square. Again, that's AB. So like before, I would have two I and j components, right? So I would have I and j component. For I component, I have AB equals to k hat cross j hat. It becomes negative I hat. And I have negative here already, so it would be alpha L sine 30. Then the other term is this I hat. So one of them would cancel out, and I have negative, so it becomes positive L 0.1 square over L cosine 30. All right, and for the j hat, I would have 0 for j component. This is for I component. I would have 0 k hat cross I hat. It becomes j hat. So I would have negative alpha L cosine 30. And then I have this one. Negative, negative, it becomes positive. So plus 0.1 square sine 30 over L cosine 30 square, or L square cosine square of 30. So from this, we can find alpha, right? We bring that side. So from the second equation, I get alpha equals to 0.1 square sine 30 over L cube cosine 30 cube. All right, and we plug it in here and we find AB, and we should get the same result as before. All right.